Hello, today we are going to be talking more about Pythagorean Theorem, and specifically we're going to be talking about the converse. Last class we talked about how Pythagorean Theorem states that if you have a leg squared, a squared, plus the other leg squared, b squared, and it is equal to the hypotenuse squared, then it has to be a right triangle. Every single right triangle, it's true that the legs added together and squared are equal to the hypotenuse squared. That's a property of a right triangle. So today we're going to be talking about the converse. Before we do that though, let's just remind ourselves the legs are always the short sides that make up the 90-degree angle, and the hypotenuse is always the longest side, and it's across from the 90-degree angle. So now let's take a look at the converse. Okay, the Pythagorean Theorem converse tells us a little bit more about triangles. Okay, it tells us that if, in fact, c squared is equal to a squared plus b squared, we can say it's a right triangle. So instead of saying it's a right triangle, therefore a squared plus b squared equals c squared, we can also say that if c squared is equal to a squared plus b squared, it has to be a right triangle. Okay? There are also some helpful things that help us categorize triangles using Pythagorean theorem. What if it's not equal to a squared plus b squared? Well, we know it's not a right triangle, but can we tell anything about it? And the answer is yes. If the hypotenuse squared, if c squared is less, okay, if it's lower, less or lower than a squared plus b squared, then we know it has to be an acute triangle. If c squared is greater, okay, if it's more or big, more or bigger than a squared plus b squared, it has to be obtuse. So we can use the converse to see, is it a right triangle? And if not, we can at least tell whether it's an acute triangle, meaning it's got at least one angle less than 90 degrees, or an obtuse angle, an angle that's greater than 90 degrees. So there's two steps to doing this when we're trying to figure it out. The first step is it a triangle? Okay, because if it's not a triangle, then we really can't proceed, right? And we've done is it a triangle before. What we're looking for is to beat the high score. So when we're trying to figure out whether the side lengths given to us, these are three sides of a triangle, are even possible to make a triangle, the first thing that we do is we circle the high score. So we circle the highest score length. Okay? So here, the highest score length, the highest side length would be 5. If this were a triangle, that would be the hypotenuse, the longest side. Okay? Then what we have to do is add together the other two. Okay, so let's see. If I have 3 plus 4, I get a 7, right? So 7 beats the high score, the current high score, after adding the other two together. So then I know it is a triangle. Yes, it is a triangle, right? Okay. So here, the highest score, our current high score is 2. When I add these together, the other two small ones, we also get a 2. Now, does 2 beat 2, or is it equal? It's equal. So since it doesn't win, a tie is not beating the high score. Tie doesn't count. So since it's not larger than our highest score or our third side, we can say that no, this would not form a triangle. Okay? Let's do one more here. 10, 11, 13. 13 is our highest, so I would add together these other two. 10 and 11 together make 21. And that definitely is bigger than 13. It beats it, so yes, it is a triangle. Why don't you pause the video for a moment and try the 3 along this side. Okay, so you should have gotten yes, no, and yes. Here I have 13 as my largest, and 17 beats it. Here I have 16 as my largest, and 14 does not beat the highest score of 16, so it is not a triangle. And the last one, 40, was our largest. And when we add these together, we get 49, which is clearly larger. Okay, so that's the first step that we're going to need to do when we're trying to figure out whether or not it's right, acute, or obtuse. First step, I have to check and see, does it even make a triangle? The second step is, what type of triangle is it? So if it does make a triangle, I need to check and see if the hypotenuse is equal, less, or more. Okay? So let's take a look at how we go about doing that process. Okay? So the first thing that we have to do is, when we're looking at the Pythagorean Theorem, you can see up here our formulas, we're squaring each of the sides, right? So for applying the Pythagorean Theorem, it means that we have to square all 3 side lengths, okay? A gets squared, B gets squared, and C gets squared, okay? So, and I would avoid putting an equal sign or anything between them. Let's just go ahead and square them. So usually first I have to check if it's a triangle though, right? That's our first step. So I find my hypotenuse, that's 5. If I add these 2 together, I get 7. Cool, it is a triangle. So I can cross this one off. We know it's a triangle. Now I'm going to take my hypotenuse, and you're going to want to put the c squared in front. Usually we do a squared plus b squared equals c squared, but you see how up here we have it oriented so that the c is in the front? It's not that important, but I feel like it helps. So I'm going to say 5 squared is equal to 25. And then I'm going to put the other 2 over here. 3 squared, and I'm going to add these 2 together, right? 3 squared and plus 4 squared, my 2 smallest ones, which is going to give me 9 and 16. Okay, and when I add all of that up and I compare 25, okay, and 16 and 9 is 25, I find that they're equal. Okay, since they are equal, okay, all right, if it's equal, I know it's a right angle. I know it's a right triangle. Okay, so this is equal to this. It has to be a right triangle as my answer. I see that that's not showing up great, so I'm going to go over here and just use a darker color, black. Okay, 25 equals 25. All right, let's try the next one. So step 1, does it triangle? Find my big boy. Okay, my biggest one is 13. 10 and 11 make 21. So I know that it is in fact a triangle. Don't have to worry about that, but you do need to check every time. Okay, so now let's see what we've got. We've got 13 squared plus 10 squared, or excuse me, 13 squared, and then the other 2, I use my small ones, 10 squared plus 11 squared. This one's on its own as a comparison. 13 squared is 169. 10 squared is 100. And 11 squared is 121. So when I add 100 and 121 together, I get 221. Okay, so if I'm looking at these, if I'm comparing them, this one is not equal, it's small. Okay, if it's small, right, if I can draw a less than symbol in between them, less than, small, then we're going to say it's an acute triangle. Okay, so this is acute, and it helps to think small angle, right? If it's the smallest one, it gives you a small angle, an acute angle. Okay, Let's try another, then I'll give you some practice. Okay, again 13 is our biggest, but we have two different small sides for our legs. So I have 13 squared, and then I'm going to take 6 squared and add it to 8 squared to compare. That's going to give me 169 again. 6 squared is 36, 8 squared is 64, and 36 plus 64 is equal to 100. Okay, they're not equal. I could say that this one is bigger. The alligator mouth would open to eat the 169, wouldn't it? Okay, so looking at that, I say that this one is big as comparison. Okay, a big one has a big angle, so it is absolutely going to be an obtuse angle. So small or less than acute equal, right triangle, and greater than or biggest is going to be obtuse. Okay, all right. So why don't you try the next three and then pause the video and check back in to see if you got them right. Remember your steps. Find your biggest one, check if it's a triangle, then put your biggest one, your C, on the left and square it. Put your two small ones on the right, square and add them together, and then see if the hypotenuse is the biggest, the smallest, or equal. Okay, so you should have gotten acute, obtuse, and right. Acute, obtuse, and right. Remember, you should be checking to see if it's not a triangle. 4 plus 6 is 10, which is bigger than 7, right? And then I would have 7 squared, and I have 4 squared plus 6 squared, okay? 49, and then 4 squared is 16, and 36 for 6 squared. That gives me a total of 52 for this side. 49 is smaller, it's less, so it's acute. This one, 40 was our biggest. These two add up to more than 40, so I know it's a triangle. Okay, 40 squared, and then I would have had 24 squared plus 25 squared. 40 squared is 1600, pretty big one. 24 squared is 576, and you can be using your calculator for this, plus 25 squared is 625. So I'm comparing 1600, and when I add those together, I get 1200. 1201. Okay, so this one, our C, is bigger. I could put a greater than sign in there, which means it's obtuse. And our last one, 13, these are greater than 13. It is a triangle. Okay, and if I skip down to the bottom, you would have gotten 169. And then 5 squared is 25, 12 squared is 144. Add those together and you get 169, right? So you had 13 squared, and you're comparing that to 5 squared plus 12 squared. Since these are equal, they're the same. If they're equal, we know it's always a right triangle. Okay, so that should have been a good review for you for Pythagorean Theorem and Pythagorean Theorem Converse. All right, last class you began a sheet that looked like this. Some of you turned this into me. The very kind substitute should be able to hand it back to you. If you have not finished the front of this page, I need you to finish the front, and I'd also like you to do the 6 problems on the back. When you've completed that, there's a walk-around practice around the room, and you should work on that and complete that and turn that in as well. So you finished this video, you're going to finish this worksheet, Pythagorean Theorem worksheet number 1, and you're also going to work on these task cards, which look like this, that are posted around the room, asking you to classify triangles using the Pythagorean Theorem Converse. I've also posted this to Schoology in case you want to look at the problems there. Thank you.